मैट्रिक्स ऑपरेशंस और इन्वर्शन के बाद आज का सेशन है रैंक ऑफ मैट्रिक्स। यहाँ हम रैंक ऑफ मैट्रिक्स कैलकुलेट करने का डिफरेंट मेथड्स पढ़ेंगे। The rank of a matrix A is a positive integer if at least one minor of order R of A is non-zero, whereas its all minors of order are plus 1, 0. The rank of a matrix are denoted by R, A, 0, R row, A. Rank matrix निकालने के 3 methods हैं. 1. By using definition with or without means of the elementary transformations. 2. By reducing into normal form. 3. By reducing into echelon form. By using definition with or without means of the elementary transformations. The rank of matrix A is the order of the largest order non-zero minor of A. The determinant method is used. But, in the case of matrices of large order, this process involves a lot of computations, so it is tedious. Hence, we transform maximum possible entries of A to 0 by applying elementary transformations and then use definition. Matlab if order is large, complexity increases, hence, elementary transformation method use करते हैं. Example A is a matrix. 3 rows 3 column, hence it is of order 3 by 3. Determinant method से solve करेंगे. Determinant of matrix A is equal to 5 times 6 minus 6 plus 1 times 18 minus 4 plus 0 times 9 to 2. This is equal to 14, which is non-zero. So, it is the largest non-zero minor of A. Therefore, rank of matrix row A is 3. Point to remember. For a non-zero matrix A, rank is more than or equal to 1. The rank of a matrix A is equal to the order of the largest non-singular submatrix of A. A non-singular matrix is a square one whose determinant is not zero. Example to find the rank of the following matrix. Solution. This is matrix A, of order 3 by 3. Using determinant method. A determinant. 1 times 24 minus 25 minus 2 times 18 minus 20 plus 3 times 15 minus 16 is 0. Here, minor of order 3 is 0, so rank of A is less than 3. So, the minor of order 2 is obtained by deleting 3 row and third column. ये determinant A है, which is 4 minus 6, which is minus 2, non-zero. Minor of order 2 is non-zero, so rank of A is 2. Example 3. Find the rank of the following matrix. Solution. This is matrix A, order 3 by 3 है. देखने से ही हम जान सकते हैं कि इसका determinant 0 है और इसके सभी minors of order 2 are 0. But all elements are not 0, therefore, rank is 1. Example 4. Find the rank of the following matrix. Solution. It is a 3 by 4 matrix, 3 rows 4 column. Since it is big, we will use elementary transformations. The rank of a matrix remains unchanged by applying elementary transformations, that is, the equivalent matrices have the same rank. Here, this element A11 needs to be 1, in this case it's already 1. We have to transform rows such that elements in these positions are 0. We shall understand this in detail while understanding echelon reducing method. Here, row R2 is added to 2 times R1 to get this, minus 2 plus 2 times 1 is 0, 3 plus 2 times 2 is 7, 7 plus 2 times 3 is 13, and minus 1 plus 2 times minus 4 is minus 9. Similarly, to reduce this element of row 3 to 0, we subtract R1 from R3, 1 minus 1 is 0, 9 minus 2 is 7, 16 minus 3 is 13, and minus 9 minus 4 is minus 9. We get this. Now to make this row 0, we need to subtract R2 from R3. 0 minus 0 is 0, 7 minus 7 is 0, 13 minus 13 is 0 and minus 9 minus 9 is 0. Here, the number of non-zero rows is 2, therefore rank of matrix A is equal to 2. By reducing into normal form, any non-zero matrix A of rank R can be reduced by a sequence of elementary transformation forms such as this, where IR is unit matrix of order R. This form is called as normal form of A. Other normal form are this and this. Here, both row and column operations are allowed. It is reduced to identity matrix this. The normal form is this identity matrix of order n. First, we need to make element is A11 position, that is this position, as number 1. Then we have transform column 1's all element below 1 as 0, and all elements in row 1 after 1 as 0 like this. Then, AE to 2, that is as 1 and other elements as 0 and so on. Let's understand this clearly with an example. Example 1. Reduce this matrix to normal form and find its rank. Solution. This is a matrix of order 3 by 4, 3 rows and 4 columns. Since order is 3 by 4 and 3 is less than 4, we can say the rank of matrix A is less than or equal to 3. First, to make this element 1, we can divide C1 by 8. We get 1, 0, 1. Then, reduced row R3 by adding it with R1 we get 0, 0, 0, 10. Now, to get 0 here, column 1 is subtracted from C2 to get C2 as 0, 3, 0. To get 0 in this position of C3, 3 times C1 is subtracted from C3. To get 0 in this position of C4, 6 times C1 is subtracted from C4 we get this matrix. Now to make diagonal, that is these position 0. Column 2 is divided by 3 we get 0, 1, 0. Column 3 is divided by 2 we get 0, 1, 0. Column 4 is divided by 2 we get 0, 1, 5 and matrix is this. Now, column 2 is subtracted from column 3 to get this column and column 2 subtracted from C4 to get this C4. Interchanging C4 and C5, we get this. Dividing C3 by 5 this matrix, identity matrix of order 3 with 0 in C4 that I3, 0. This is normal form, rank of the matrix is 3. By reducing into normal form P and Q form. Example 2. Find two non-singular matrices P and Q such that PQ is in the normal form, where A is this matrix. Also, find rank of it. Solution. This matrix is of the order 3 by 3. Here, approach is, both row and column operations are allowed. Matrix A of order M by N is equal to identity matrix of order M into A into identity matrix of order N, and rank of matrix is size of the identity matrix. So, matrix A of order M by N is equal to identity matrix of order M into A into identity matrix of order N. To obtain matrices P and Q, we reduce LHS to normal form. C2 is transformed by adding C2 with C1 and C3 is transformed by adding C1 to it. We get this. Since this is identity matrix with order N, that is N represent column, we perform same operation here too and we get this. No operation is involved here, as this is of order M which represent row. Now, R2 is transformed by subtracting R1 from R2 and R3 is transformed by adding -3 times R1 to R3. Since this is identity matrix with order M, that is M represent row, we perform same operation here too and we get this. No operation is involved here, as this is of order N which represent column. Dividing R2 by 2 and adding -4 R2 to AR3 we get this, and this is changed to this. Transforming C3 by subtracting C2 from it we get this which this, and this is changed to this. This is unit matrix of order 2 and can be written as this, which is normal form. Rank of the matrix is the size of this unit matrix, which is 2, and non-singular matrices P and Q are these two. By reducing into echelon form. Approach is: only row operations are allowed. Reduce matrix to upper triangle. Rank of matrix A is equal to number of non-zero rows. Let's understand it with an example. Example 1. Find the rank of the given matrix by reducing to echelon form. Our objective is to reduce this matrix to upper triangle, that is, all the elements below the diagonal needs to be 0. In echelon form only row operations are allowed. To get all element below 1 in one cent column 0, we perform row operations, that is, R2 is transformed by adding minus 2 times R1 to R2, 2 plus minus 2 times 1 is 0, 4 plus minus 2 times 2 is 0, 3 plus minus 2 times 3 is minus 3, 2 plus minus 2 times 0 is 2. R3 is transformed by adding minus 3 times R1 to R3, 3 plus minus 3 times 1 is 0, 2 plus minus 3 times 2 is minus 4, 1 plus minus 3 times 3 is minus 8, 3 plus minus 3 times 0 is 3. R4 is transformed by adding minus 2 times R1 to R4, 6 plus minus 6 times 1 is 0, 8 plus minus 6 times 2 is minus 4, 7 plus minus 6 times 3 is minus 11, 5 plus minus 6 times 0 is 5. Row 4 is transformed by subtracting it with row 3. Minus 4 minus minus 4 is 0. Minus 11 minus minus 8 is minus 3. 5 minus 3 is 2. Interchanging R2 and R3. We get this. Transform R4 by subtracting it with R3. We get this upper matrix, and it is in echelon form. The rank of matrix is equal to number of non-zero rows in echelon form, which is 3. Example to determine the rank of the matrix by reducing the given matrix to echelon form. Solution. In this matrix, we need to do row transformation of R2 by adding minus 3 times of R1 to it. 3 plus minus 3 times 1 is 0, 6 plus minus 3 times 2 is 0, 9 plus minus 3 times 3 is 0, minus 3 plus minus 3 times minus 1 is 0. Similarly, R3 is transformed by adding 2 times R1. 2 plus minus 2 times 1 is 0, 4 plus minus 2 times 2 is 0, 6 plus minus 2 times 3 is 0, minus 2 plus minus 2 times minus 1 is 0. This is echelon form. Rank of this matrix is number of non-zero rows, which is 1. Example 3. Find the rank of the given matrix by reducing to echelon form. This is a matrix. First, to change element A11 to 1 divided row R1 by 6, we get this: 1, 1 by 2, 5 by 6, 3 by 2. Now, we have to get upper triangle form, that is all the elements below the diagonal needs to be 0. So, row transformation of R2, R3, and R4 is done. R2 is transformed by adding minus 5 times of R1 to R2. R3 is transformed by adding minus 3 times of R1 to R2. R4 is transformed by adding minus 2 times of R1 to R2. We get this: we got 0 in all these positions. Now need to get 0 in this position, for which we subtract R2 from R3 to transform row R3. By adding R4 and R3, we get 0 in this position of R4. Now we got upper triangle matrix, that is all element below the main diagonal is 0, it is in echelon form. Given rank of given matrix, A is equal to 3. So, the number of non-zero rows of A should be 3. K3 is equal to 0. K is equal to 3.